Hey everyone, Krishna here and I welcome you all to this channel. So let's design Google Drive or Dropbox in this video. This will be high level design interview question and I referred content from Hello Interview and System Design Interview by Alexu to understand the system. Okay. So let's start designing this Google Drive. So you already know that we use Google Drive for uploading the files, downloading it across different devices, and then there should be a proper sync. If I modify a file on one particular device, then on all other devices where the file is available, it should get properly synced, right? Those are a couple of features this Google Drive basically provides. So yes, let's first note down all the functional requirements. The first is like uploading the file. Second is download it. Third is like it should get synced across all devices. Then there are a couple of other functional things like there should be notification, collaborative documents, and all those features that are available. But those are out of scope for now. Okay, so we will just focus on these couple of features right now. And let's talk about non-functional requirements as well. So here, the first is like obviously, if we talk about cap theorem, so system should be highly available compared with the consistency, right? So it should be highly available because see, we don't want to bother about consistency here, right? So at any point in time, if I modify a file, it is fine that if it gets updated in 10 or 26 seconds in all the other devices, you're not bothering about consistency right over here. So that is the first thing. Second is there should be low latency. Whenever we talk about this low latency, right? So when user basically start uploading or downloading the file, yeah, there should be low latency because we don't want to take a lot of time to upload or download a file if file size are small or even big. There should be again resumable feature. If file size is pretty much huge, right, like 10 GB, let us suppose, and when users start uploading that file, and in between that there should be there could be a possibility that internet issue due to some network connectivity issue, user may lost a connection and stopped in between while uploading the file, right? Then when a user gets back, we should let user to upload from where he got disconnected, right? So that is something what we have to consider. And obviously user may upload images, and also it is actually a private thing, so the platform should be highly trustable. Okay. Yeah, I think a huge file size, like let us suppose 10 GB file or 50 GB file also, users should able to upload it. Okay, so that is something what we can consider a reasonable feature. Okay, now if we talk about the QPS, right, so obviously let us suppose 100 million users are there on our system, and daily 1 million active users we have. Okay, so if 1 million active users we have, and uh, if we try to talk about the throughput, right, so it is like obviously 10 power 6 divided by 86400. That is the value that we get it generally when we try to convert in seconds. So here it looks like if we divide them, right, so on an average, like I'm not considering this 86400, I'll just simply consider that 10 power 5. So 10 QPS is something what we get it. Okay, so these are our queries per second. And let us talk about the storage as well. So here let's suppose 1 million active users we have on daily basis, and they are uploading 5 MB file two times in a day. So it is obviously going to be 10 power 7. So it is that is how the data looks like, which we can say it as like 10 terabytes. Okay, so if we convert it in TB, so on an average, like if we discuss about this yearly basis storage, so this will be like 3.65 petabytes of data is something what the storage we require. Okay, so this is all about the storage and queries per second for read and write. Now let's try to design it. So first, before designing it, right, like let's talk about entities as well, core entities. The first is like obviously user is our class. Then there is a file, then file metadata. Then there is like across device uh, entity could be there. So yes, similarly like there could be other bunch of other entities as well. Now let's talk about APIs. Okay. So the first API is obviously to upload. We require post API, which looks like API slash post or upload. And inside body, we have to send users info for authentication and all. Make sure that user is properly authenticated and he has authorized to upload and all. Now, next is obviously file metadata is something also we have to share, okay, along with this request. Now, this will be in body. Next is download API. So to download a file, obviously it is get, which is like API slash get or download, we can say. And here we have to provide the file ID, the file which we want to download. Okay. The next is like sync service to ensure that it is properly synced across all devices. This again a get request. We can talk about this particular sync service. Like we can we may want to use here websocket and all, but it kind of like will rely on REST API only at end. But we'll discuss about this. Changes and the time duration is something what we can provide here, where equals time updated time. Something like that. The sync service would be. So yes, these are a couple of APIs we have. Now let's first design low level, like how it looks like, and then we'll talk about we'll deep dive into it. Okay, let me just make sure that these contents are, this should be visible properly, and this is also like just rearranged things. So okay, here these are our clients, right? So clients start interacting with our system. So obviously, we will be using here middleware before these requests go on server. So we will be having here API gateway, load balancer will be there, and then next is like rate limiting to not get exposed, or I mean we have to ensure that users are making requests based on the limits that we set. Then obviously authentication and all authorization, those things will be there. Okay. So user first interact with this API gateway. These are the clients. Okay. Now the first thing is when user interact with this based on the request, right? Whether it is a post request, get request, and all. Based on that, request goes to particular server. So first is our obviously to upload the file. We will be having upload service. Okay. So we have here for uploading the file is our upload service. Okay. We can name it as file service only, because through this we will be performing multiple operations to retrieve the file and all. We can use it. Okay. So we can maintain other service as well. There is no problem with that to download or read the data, but this is fine. Like we can use this one as well. Now this is for uploading the file. Okay. It will be post. That means like we are uploading the file to the file service. Now this is on the server, right? What we basically do is along with this request, we have to send file metadata, and obviously to store that file, the image or video or document, we will be requiring here blob storage. Okay, so this is our blob storage upon which the files are getting uploaded. So this could be an S3 and all. So we will use S3 to upload that file, and to ensure the file data is saved, the metadata, we'll be using here a database. Okay, so this database could be anything. We can rely on I mean NoSQL or even SQL. I'll go with SQL in this video. Okay. There is I don't think like we have to worry about a lot about database to choose which database can be perfectly fit fine over here. We can go with NoSQL or SQL only. Okay. So I'll be choosing here MySQL DB. So the query is like the first thing is like we'll be having here file DB. In this file DB, we have the structure is kind of like this. I mean the columns first is like file ID. Second is URL ID. I mean URL link. Okay, where the file is actually uploaded. Along with this URL link, then the meme type, like what is the file type we have. Next is obviously updated date if we are updating uploaded time. And yeah, bunch of these meta information. Obviously, like user ID is also there. So the user who has uploaded this file. So we will be requiring another users table, and this user ID is actually foreign key from this users table. Okay, we have this user DB. From this user DB only, like in this one user ID. This is for user authentication and user information that we store it in this user DB. Okay, user ID, then email name, and all those things will be available. So this file, whatever file we are uploading, the user ID is something what we get it via this post only, authentication that happens via this API gateway, and then the user ID is also we are storing it. Okay, and then next is like status and all those things will be there. Okay, whether the file has been uploaded or not, that is the status that we will be having. So there will be interaction with this here, this one. Okay, now next is let me just make it small. Once user start uploading the file, right? So he has to first communicate with this API gateway, and then from the file server, the file is basically gets uploaded to the S3, and then there is a file DB. In this one, the metadata information basically gets saved. Okay, that is our first way of uploading the file. Download is kind of same. So whenever user requests to download that file from a remote device, or from, let us suppose user uploaded that file from the mobile, and on the Windows he want to get that file, okay, on the Windows operating system. The path is kind of same. So from here only he can get that file from the using the file service. And this is the get request to get the file, okay. So just he has to provide a file ID, and from this S3 he can download that file, okay. So that is the interaction for download as well. Now this is going to be a high level design. Okay, so we'll deep dive later. Next is like to make sure that the file is synced across all devices. Let us suppose client from mobile device, he has modified the file, and now he want to make sure that all the changes that he has done should get reflected across all remote devices. For that, what we can have is like we will be having here sync service. Okay, so using the sync service only, the file gets synced across all devices. Okay, so the sync service can communicate with this file service to get all latest changes that are available for that particular file, and that can get reflected to devices which basically has that file. Okay, so that is how the flow basically looks like. It is a completely high level design, how the system basically looks like and all. Now let's deep dive into different things. Okay, the first is like when users start uploading the file. Okay, let us suppose the file size is actually huge in size. Let us suppose the file size is of 10 GB. Is it really a preferred way? Like we can send that file along with this particular API gateway, and then file service through that the file gets uploaded to S3, and then we update that metadata into the file DB. Obviously not, right? Like even if we try a few of these API gateway and all, whatever the request that we make it, they have some limitations. Okay, so we cannot simply send that much of huge data along with this REST API. Okay, so what we basically use here is like instead of server uploading the file on this S3 and all storage devices, we ensure that the file is basically uploaded by client itself. Okay, so how that works is like when user want to upload a file, he does not send that file Instead, file metadata information, that is something what client send to this file service. So on this file service, what we can do is we can chunk that file. Okay, let us suppose this is the entire file that we have. Okay, so we will calculate checksum of that file. Let us suppose the file is of 10 GB. That information is something what we pass it to the file service. Now this 10 GB file basically gets chunked across 5 MB of size. So this is like 5 MB size. Then going on, like it will get chunked across all these layers. Okay, so 10 GB file gets chunked in 5 MB of sizes, and based on that, whatever offsets we get it, like from 0 to 5 MB, that is one chunk. From 5 to 10 GB, that is another chunk. So at the end, like we may end up with 3 or 4 MB of size. Like it depends, like based on the calculation and all. Those chunks are basically get created for that particular file, and then this file service request that to get the pre-signed URL from this S3. This file service make a request to the S3, and S3 basically provide all for all different chunks. Okay, whatever the chunks that we calculated it, right, 5 MB, for all those chunks, it provides pre-signed URLs, okay, to the file service. Now with the help of those pre-signed URLs, what we do is like we create another chunk table. Okay, now performing normalization and all, using normalization, we will be having another chunk table. So this is our chunk table that we have. So in the chunk table, obviously this is our chunk DB, and inside chunk DB we will be having each chunk ID. It is chunk ID. Okay, and next is like URL, chunk URL. Okay, so URL for that chunk ID, and status, whether the file has been updated, the chunk has been uploaded to the S3 or not, that status, and then updated time and all those things we will be having here. Obviously file ID is something what we will be having here, so that like a particular file can have multiple chunks, right? Obviously, so file ID is something what we can provide. So this will be, this file ID is actually the foreign key from this file DB. Okay, so that's how the chunk table basically looks like. So we calculate all those different chunks. So we request from S3 to provide pre-signed URLs for all those chunks where the file is something what we want to upload. And once we create all these DBs and all, we fill information. Along with this request only, we send client all those pre-signed URLs. Okay. Now what client does is like he start uploading the chunks. Okay, in the form of chunks. That particular file he will start uploading to S3 directly based on the pre-signed URL. Okay. So there will be time limit and all. Obviously, like client cannot just keep opening this connection to S3 and just keep on trying to upload a file. There should be time limit and all. Along with this S3 or whatever the URLs, pre-signed URLs that we provide to the file service, there will be a window. There will be, I mean, complete proper authentication. Like this user is only the trustworthy user who is uploading the file and all. Those things will be properly maintained right over here. Okay. So now client for each chunks, like whatever the URL, designed URL, pre-signed URL that we got it, there the file start getting uploaded to S3. Okay. So now this way, like what we are performing here is like at any point in time, let us suppose user gets disconnection from internet, and then again he backs. So majority of chunks, let us suppose they have been uploaded on the S3, then he can resume from which the chunks has not updated into this chunk ID. Okay, their status is not uploaded. Those chunks he can again upload it, rather than uploading all the previous chunks he already uploaded. Okay, so there will be delta sync, like only chunks that needs to be updated or that has to be updated into this S3. Those chunks only again he can start uploading it to the S3. Okay, so that is something what we can consider for resumable upload. Okay, so yes, with this chunk, we can obviously like make sure that based on the internet speed, we can perform parallel operations and all. Like parallelly, we can start uploading each chunks into the S3 and all. Obviously, encryption is something what we have to take care of while uploading it into the S3. So those all operations we can perform it, and then those files will be available on S3. Now, the moment the file is available, let us suppose one chunk has been uploaded on S3. So we have two ways to update the status of that chunk. Okay, the first is like S3, once the file is uploaded to S3, client will make a request to this file service and it tells that this particular chunk has been uploaded. Now file has to verify it. Okay, so this will be like even if client says that the chunk has been uploaded, client has to verify whether the chunk is actually available in that S3. If it is available in the file DB, like in the chunk ID, the status has been updated to uploaded. Okay, so that is something what we can maintain right over here. That is one way. The other way is like S3 basically provides a multi-part upload. So at any point in time, the file has been uploaded on S3. It generally sends a notification from here to these servers. Okay. So obviously, based on the S3 notification, the file server update the status. Okay. So those are a couple of ways through which like we can update these tables and we make sure that the data is actually updated and this DB is basically maintained properly. Okay. Now this is like for uploading the file. Okay, so we covered this uploadation. Now for download. Okay, so download is pretty much same. Like let's suppose on other device user has logged in and now he want to download that particular file that is available on this S3. So he has to basically make a request, and from here the whatever file ID has made request from this chunk DB and file DB, all those URLs this client basically gets provided, and then the client can again interact with this S3 and start downloading it from here himself. Okay, the same path will be follow for download as well. Okay, so yeah, it is kind of same. Now next is like we have to talk about the sync service, right? Like we want to sync it across all devices. Correct. So since it is now available on the first device and on the second device we downloaded that file. Now at any point in time, let us suppose the first from the first device client has modified the file. So it should get reflected on the second client's device as well, right? So let's talk about the sync service. Okay. So how we can create the sync properly? That is something what we will discuss. So first is like client has modified, okay, some content on his local machine that needs to get reflected and it should get updated properly to S3 and these databases as well. For that, what we can do is we can utilize OS watchers. Okay, for each operating system we have watchers. Okay, so at any point in time, if we make any changes in our local file, okay, so what it does is like this OS watchers, like Windows has watcher. I mean, each operating system has watchers. Okay, so if you make any changes in a file, those watchers can notify. Okay, so our whatever Google Drive client that is available on this one, we require here local database as well. So there will be a local database for each file, like it will hold a reference like where the file is actually available locally on the machine. Okay, so local DB is something what we require at any point in time. Chunk ID, chunk status, everything, like for chunk ID, right? Like we have to make sure that whatever chunk that we are modifying, it should match with this chunk ID. Correct. For that, what we can do is like we can create a fingerprint. Whatever particular files chunk that we have, we can create a hashing of that particular bytes. Okay, and that is our chunk ID. Okay, so fingerprint is something what we can use to make sure that whatever chunk that we modified, it should be I mean matching with this chunk DB as well. Okay, so for that, like we have to maintain here local DB. Now at any point in time, let us suppose on local machine, like on my mobile phone, I have modified some content in that particular file. So based on the chunks, like we have to resolve like so these watches, what it does is like it will notify to this Google Drive client. Okay, this file has been modified. So we have to wait whether the file is stable or not. Okay, within 1 or 2 seconds, let us suppose I have modified multiple things. So in 1 or 2 seconds, we verify that whether the user has stopped modifying, the file is stable now, and we collect all those modifications and we have to figure out like which particular chunk that modification has been done, and based on that the request goes to the file service that this is particular chunks which got modified. So from here again, like it update the status, like I mean status has been modified. So that is something what we have to update into the chunk DB, and from there like we have to get all the links on the S3 where the file is basically available, and we have to provide back to the client, and then again client will update into the S3. So the path is going to be the same again, whatever we previously followed for posting that file. Okay, it is kind of same, but only thing is like we will be using OS watchers to make sure that at any point in time user modifies the file, we have to just detect the changes, and with the help of that, Google client can, this Google Drive client can get those updations, and updation process happens, okay, by this way. Now, once the file has uploaded, the status again we have to modify it from modifications to updated, okay, and updated time is also we have to update. Now on the other devices, like let us suppose we there are multiple users who are actually having these files on their local machine as well. There the files should get synced, right? For that also, what we can do is, see here we have multiple ways, okay, couple of ways we can perform to make sure that the file is synced across all devices. The first is like, obviously we can use here WebSocket, okay. So we can create a WebSocket, so with the sync service, at any point in time, if changes has been detected through file service, like it is updating this one. So WebSocket is actually two-way communication, right? At any point in time, this data has been modified, this sync service get notifications, and it basically start downloading those changes, whatever the chunks that got modified, and it will start reflecting across all devices. But obviously for this system like this, like where we are completely fine, where in 10 seconds or 20 seconds also the data gets modified across all devices, we are completely fine there. I don't think like we have to rely on this WebSockets, right? Like WebSocket is like within a friction of seconds, like any modifications that has been updated, that gets reflected across all devices. But that is not the goal here, right? So we will be having refresh button and all. So at any point in time, if client want really latest changes, he can hit the refresh button, he can fetch all the latest changes at that particular point itself, right? So that feature is also available. So here, instead of relying on WebSocket, we can simply use adaptive polling. Obviously there are long polling, short polling and all those options are available, but in long polling, a user make a request. If no data, then the request drops, and again user has to make request. But with the adaptive polling, right, how things works is like, first let us discuss about adaptive polling as well. In adaptive polling, client first make request, okay, from remote machine. Like let us suppose from here, the client is basically checking whether the file has been uploaded or updated or not. He make a request, okay, to the sync service, and sync service check whether the file has been updated or not, okay. So in first, like the request goes every 1 second, the request basically goes, and now we saw that there were no updates, okay. After a certain point in time, then the request has the whatever request that we are making, it goes to 2 seconds, okay. So every 2 seconds now the request started happening, because there were no changes we detected for 1 second. Now in 2 seconds also, we don't see that there were changes in the file. So after 2 seconds, like we can have 5 seconds request. Okay. After every 5 seconds, the request start making to the service, and then it checks that whether the file has been modified or not. In 5 seconds also, if we don't see, like this is like how we are making requests limited. Okay. So in the next 10 seconds, the request start making. Okay. So after every 10 seconds, the request has been created and checks that whether the file has been modified or not. If after 10 seconds we detected that the file has been modified, like the status has been updated time, whatever the time that we have currently with us within the local DB, like based on this chunk ID, if that has been modified, then we have to ensure that all the file IDs, okay, all the chunk IDs that got modified, those we get it, and we will update it across all devices. Okay, so these are the chunk IDs that got modified, and you have to get it from the S3. So again, these whatever changes that we got it from the sync service, we provide all those chunk IDs updations to this particular remote devices, and they start downloading from the S3. Okay, that's how things we can use it. So now the request goes again back to the 5 seconds, because he detected that the file has been changed. Again from 5 seconds, let us suppose the file has modified, again request from every 2 seconds, the request start making and checking whether the file has been updated or not. This is how we can rely on adaptive polling, because let's suppose the user has uploaded a file and he's not making changes at all. Then with the help of this adaptive polling, right, so we can stop our request and we can make request limited. Okay, so that is something what we can leverage using this adaptive polling. So we don't want to make sure that we are just making a lot of requests to the service and keep on checking whether the file has been uploaded or not. Okay, so yes, we can use adaptive polling here to ensure that if there are any changes through this sync service, we can update update it across all devices. Okay, that is like relatively better way to ensure the syncing is happening across all devices. The other way is like obviously when let us suppose user has modified a file, and through file service we are ensuring that this file whatever the chunks that we have, those particular chunks has been updated and all those information we are driving. So during that time period only we can create here an event. Okay, so like we can use here Kafka. Okay, so in the Kafka we can create those events. Okay, so we have to make sure that like on all devices where this particular file that changes that we are updating, those device information we have with us, so that all those devices are basically the consumers. Okay, so we put it into the Kafka. It is kind of an event like this particular chunk has been updated. So that is something what we create here. That is an event that we create here, and all the clients who are actually available, those are the consumers. So through sync service, like they can retrieve those events, and based on that they can download the files. Okay, so that is another way. So we can introduce Kafka here, and via Kafka only, like it is kind of a event that generated like a particular file has been modified, and we can discuss it with this particular service, and then it provides updates to the remote devices that we have. Okay, there is another way, but obviously like this whatever that particular this Kafka that we are introducing, the events that we are producing, still like it is less relevant compared with this adaptive polling. Okay, like why I'm saying like that is like basically Kafka stores events. It basically solves different problems, right? And if I modify a file and it triggers as an event, again, if I try to modify it, store it as an another event. Okay, so there is no like if multiple events that we have, and based on those events, we are keep on making requests. So it is like error prone, right? Like we are not maintaining the order. At any point in time, if a client modifies the file, and again quickly he modifies the file, so it store it as an event. Okay, so these events basically gets back to the clients, the remote devices where these events were moving, and based on that they start looking into that one. There will be obviously version mismatching and all, obviously because whenever we modify the file we have to maintain the versions, like this is the version latest version that we have, and it got modified, so it doesn't track all those versionings and all, right? So this Kafka. So yes, we can introduce, but there are some other challenges that we have to face if we try to introduce Kafka to get these events, whatever client making changes as a form of event into this one. Okay. So yeah, these are a couple of things that we can have here. So we will be reviewing this Kafka, and we will rely on this adaptive polling only for now. So yes, this is all about high level design of this particular system. Yeah, and I think like we can introduce notification and all those things will be there. So yes, that's all I guess. I think we discussed everything. For low latency, what we have to do is like we are creating chunks and we are uploading it in form of that data. Resumable upload feature will be there. Platform, obviously like we have to introduce here proper authentication, authorization, and SSL termination. Those things will be there. A system is actually highly available because even if I modify it from this particular device, and still user is seeing previous version, it is completely fine. So that is something we already discussed, and yes, all the functional requirements has been coded in this video.